So, the epsilon-delta definition. It often feels like a giant leap from intuitive limits. Where do you usually get stuck? It's the whole for every epsilon, there exists a delta part. I get the idea of closeness, but putting it into the formal proof structure, especially for something like f x equals x caret 2 or f x equals 1/x, feels impossible. That's perfectly normal. The core idea is this: we want to show that we can make f x arbitrarily close to L, within epsilon distance, by making x sufficiently close to a, within delta distance. The challenge for non-trivial functions is finding that delta in terms of epsilon. So, we start with the f x L epsilon and try to work backwards to find x a delta? Exactly. Let's take f x equals x caret 2 and we want to prove lim x dash 2, x squared equals 4. We start with x caret 2 for epsilon. Can you factor x caret 2 for? That's x2, x plus 2. So, x2, x plus 2, epsilon. Great. We need to isolate x2. We have x2, x plus 2, epsilon. Now, x plus 2 is the problem. It depends on x. We need to bound it. If x is close to 2, let's say x2, 1, what does that tell us about x? If x2, 1, then 1x less than 3. So 3x plus 2, 5. This means x plus 2, 5. Fantastic. So we have x2 asterisk 5 epsilon, which means x2 epsilon slash 5. Our delta must therefore be min 1 epsilon slash 5. The 1 comes from our initial bounding assumption for x plus 2. Aha! That's the part that always confused me, how that min value appears. It's like we need two conditions for delta. Think of it as target practice. Epsilon is how close you need to hit the bullseye, L. Delta is how precisely you need to aim, x. For x caret 2, if you're too far from 2, the x plus 2 term can blow up. So you first aim generally close, delta equals 1, to get x plus 2 under control, then aim very precisely, epsilon slash 5, once x plus 2 is bounded. Okay, that analogy helps. So the action plan is always to start with ef x L epsilon, manipulate it to get xa isolated, and if there's a variable term left over, bound it by assuming an initial, usually simple, delta. Precisely. Don't be afraid of that initial assumption for delta. It's a standard technique. Practice with linear functions first, then x caret 2, and finally functions like 1/x to build confidence.
Enjoying this? Follow Thula Academy for more.
Visit thethula.com to join the world's first virtual campus.